Great. Okay, so this week, Vasily is going to present to us performance bar tips and tricks. Thanks very much, Vasily, and I'll hand it over to you now.
Okay, so yes, today I'm going to talk about the performance bar. It's a very useful tool I used in the past and still use when I need to work on some of the performance issues. So let's get started. So first of all, we have a documentation page about the performance bar. Yeah, feel free to review it. It has some information about what means what, but I think we're gonna go through all of these points, all of these features of the performance bar and see how it works. So first of all, if you don't have performance bar enabled, you can use this keyboard shortcut P+P. So let's say we have like a GitLab page. I press P and B. Okay, wait a bit. And the performance bar appears. Nice. So let's take a look what we have here. So first part, it's a number of the SQL requests. So the number here is how long it takes to execute all of them. Second number, it's a number of the SQL requests that we had to execute to show this page. If you click on that, we see a list of requests like sorted by the duration. So the heaviest request should be on the top. And here you can see the request itself. If you want to know from where the request is like coming from, you can take a look on the spec trace. So it's pretty useful. For example, if you notice that the page is slow, you can take a look and see. So one of the first of the requests might be one of the biggest problems. In some cases, it's not about the one heavy request. We might have a problem with n+1 requests. So let's say instead of like loading all of these users, and we have like 1,000 users of the page, instead of issuing one request, we make 1,000 requests. So for that, there is like a notification that appears on the performance bar that something is wrong. You have too many of the requests. But what I do, let's say, I just like check the list of requests, and if I see some like patterns, repeating patterns, then I just like check, okay, maybe that can be the problem. So you can, let's say you can select some part of the request like that and see, okay, so it's only one occurrences, so it's probably not this request. But let's say we have some like select users, for example. Let's see. So we have two of these requests as the search tool shows to me. So that's the first part about the Postgres. Second part that might also contribute a lot to the performance of the page is the GitLab. So if you click on that, we see, okay, we have 3 calls here, and we see the name of the call. You can also check like from where this call was issued and have some like extra information about that. And again, there are some pages that depend on the GitLab heavily. Let's say if we need to fetch lots of commits, then GitLab will be probably one of the heaviest part. And improving the performance of the GitLab might be a solution to improve the overall performance for this case. Okay, next one is Redis. Usually Redis is not a problem, but sometimes it can be. So it's kind of the same idea. You see a list of the Redis requests. And yeah, if you notice something weird, then you can also dig deeper. So this performance tool, it's kind of good starting point if you have like a performance issue working on. So you can just open the page and take a look. Probably like after some time, you will notice something weird and it will be a good starting point for your investigation. So other parts I don't really use because they mostly related to the front end. For example, this one shows some of the front end related information, how long it takes like to fetch some assets. So I usually don't rely on this one. So download, I think you can just download all of this information as a like CSV file or JSON file. Also, I don't use that. Then this field, is kind of useful because sometimes for our page, we may issue multiple requests. And for example, we are not interested in the request that loads the main page, but we have some of the dynamic requests triggered by the JavaScript that, for example, fetch some of the extra information. For example, this like logs tree. And if you click on the logs tree, then it refreshes and you can see the information about this particular request. So when you investigate, so pay attention to what request you are investigating into, because it might not be always the default one. It might be one of the extra requests that we issue to fetch some of the extra information on the page. And I think not the most interesting, but kind of useful part that I used a lot for, okay, Sean, I see you have a question. I don't hear you.
Yeah. Sorry, Vasily, can you explain again? I didn't get the difference between logs tree and the regular application.
Okay, so when we load the page, let's say I'm opening the network part and I refresh the page. So we have our main GitLab request. So this request, the GET request to the GitLab, and the information connected to this request we see right now. But let's say we have this GraphQL request, this one, that gets the last commit information. To see information about this request, we find it here in the list, and then we see what do we need to get how many like SQL queries we executed, how many GitLab requests it triggered. So we have this information for this particular request.
Okay, so does that mean that GitLab is the main page load?
Yes.
And then these other ones are things that front end's calling as separate requests. Okay, got it.
Correct. So yeah, we have some of the dynamic parts, and these dynamic parts triggered by JavaScript when after the page is loaded or on some user action. For example, if you have some extra request on click, then you can click on something and then you will see the new request appeared here.
Got it. Thank you.
So yeah, okay, you're welcome. And another interesting part that I used a lot when I was investigating the Banzai performance issues. So just a few words about the Banzai. For our markdown documents, we have a special tool that allows us to convert the markdown representation into some kind of like a rich content. So we replace the links with the actual links. So when we, for example, have hashtag number of the issue, the Banzai tool will replace it with the actual issue link and will put, for example, the name of the issue on demand and so on. And this part usually causes some problems because it's quite heavy and there are some particular files. One of them is this changelog file. As you can see, it contains lots of links, and loading this file was quite a problem. And I think it's still a problem because it's kind of grows indefinitely. So we have lots of the information about it. It's not properly rendered right now. I think it's not sure why. I think because the size of this file got so big, so we kind of stopped doing that. But if it's renders, then it will be lots of links. And to understand like what's going on, because sometimes it's not clear, we have the flame graph. So flame graph, I already loaded it because it might take a long time. By default, it looks like that. And it shows you the time the code spent in every module, in every function. And by default, so in time order, I don't use it because we have lots of the repetitions here. I prefer to group the stuff together by clicking link heavy. And here we can have some information. So overall, it took like around 28 seconds to load this page. And basically starting from the top, or actually 30 seconds, starting from the top, we see some of the Puma thread request. So that's not something that I pay attention to. I usually scroll down till I see this kind of separation. So we have a main thread of the execution, and then we have several different parts of the code, different functions that execute. So for example, here what we have, it's a part of the bonsai and it's kind of separated in two parts. So to optimize that, I was looking into different execution flows. For example, I can try to think about like, what can we optimize here? So it takes 22 seconds and 64% of the request. So significant amount. I think it's a good optimization target. And let's see what we can do here. So if you look further here, I see some of the active record each. So it's a signal for me. So here we deal with some of the queries. And it's probably like a long query. We like load lots of the merge requests, issues, links, and here we do some kind of iteration. So that signals me that we deal with lots of data coming from the database. So one of the ideas can be like to improve the database query by loading less data, or like, oh, I don't know what we can do as well. Maybe checking going back and checking the query itself. That's actually how the query looks like. And maybe looking for some of the optimization, optimization ideas, what we can do about that. It can be one of the options.
Indexes.
Indexes, yes, but I think for this particular case, it's kind of an exception. It's like you actually need all of this information about all of the merge requests, because you need to know if they actually exist, and you need to know some extra information about the merge request name, for example, to build the necessary links and so on. What else? There are some parts that might not be related to the database, but might be close to the code itself. So yeah, I see a question.
Yeah, it's to know. Sorry, I missed the beginning of the meeting. I was kind of distracted. But like for the bonsai thing, do we need to know if, like, for instance, the MR existed at this point in time, or do we need to know it if it existed every time it's actually checked? Every time the markdown is actually checked.
At the time of the markdown is checked.
Every time. Okay.
Yes.
Otherwise, I had kind of an idea for an optimization, but yeah, if it's every time, it's not gonna help.
I think we still can optimize it somehow, and like I think we can afford some of this like stale data, because let's say merge request was created, it can be closed later, but usually it's already there. So yeah, we can discuss about the optimization idea. So I think we have an issue for that.
Okay.
Maybe in this particular case, I think maybe subquery can help, but it depends where do we, how do we receive these merge request IDs, whether it's from the database or from other,
so it's like,
can we, when you have a second, we have a look at I don't quite understand the structure of this graph.
Okay. So it comes from the top.
So stupid question, sorry.
Yeah, no worries. It's okay.
No such thing as a stupid question, unless I ask it.
I can push the limits on that, Sean.
Okay. So it's kind of, so we have like a code that executes some other code and some other code. So it starts from the top. On the top, we have Puma that deals with the request. So most of the time contributes to the Puma, because everything that happens, it's inside of this like Puma execution flow. And then if you like scroll down, we can see, okay, so now we have like some RAG taking a part of that. We have some like Rails, like active dispatch, active support, Sentry, and it kind of takes less and less time. So we're kind of going from the very general piece of code that, let's say, at any point of time, we can say, okay, we are inside of this code flow, to some of the smaller flows that happen inside of this process. So just to be precise, for example, so We start with a Puma here, then we go to the Rails at some point, then we start rendering some templates. For example, here we use like action view renderer. It happens inside of the Puma flow, but it's kind of a smaller piece of that. And it gets smaller and smaller and smaller, and we kind of getting to the like smaller details. So here it's already like a bonsai logic of the representation, but it's included into the Puma flow, included inside of the Rails flow. So, and the problem, usually you can spot the problem if you scroll down here, because this part, it's your code that you like have written, and it's probably not the case like for the, it's something that you can adjust and like fix. Hope I answered your question, but if it's not clear, can you rephrase it? Or
Yeah, no, that makes sense. Sorry, no, it's just more the visual. I understand that it's the stack of this is like the call stack or whatever, but I just don't understand looking, you know, in rows. Like for instance, if you take the row above the one you've selected, I don't understand as we look right along the graph. What are they now nested calls, or so I understand vertically that they're within each other, but then horizontally, I don't understand.
Okay, I see. So what it means, for example, we have this perform filter function, and inside of this perform filter function, we call the reference filter call. It's like one of the functions that called inside of that, and another function is pipeline filter call. So we have like two functions inside of one, and we have like and it's kind of splits to the smaller pieces. And sometimes on the edge of these like smaller pieces, you can see, oh,
if their own calls.
Yeah, might have some like sanitize transform node. So it looks like we doing some kind of like processing of the user content and removing some of the, maybe some of the script lines to prevent some XSS like problems and so on. And kind of happens on the like one node inside of this markdown document. So yeah, for some of the this particular tool I used a lot for the bonsai rendering, because it's very nested and seeing like a big picture what function contributes a lot to the final time is quite useful. Okay. So any questions about this performance tool, these graphs? Okay.
Yeah, follow-up questions to Gavin's. Okay, so the horizontally, those are sub calls.
Yep.
If I understand correctly, but where are those gaps in between? Is it not supposed to be like all filled in, because it represents how much the main query, how long the main query has been taken to finish?
I'm not sure what gaps you're talking about, like this gap or like.
Yeah. For instance, like between bonsai filter reference, load records, parents, and Nokogiri,
This part, okay.
Yeah.
So here it's kind of, it's maybe like a representation thing, but sometimes one of those like final functions of this like call stack, it just occupies like lots of time. So it's, let's say it's like a final function. It does some heavy processing, and it's on the same level as a load records per parent, but load records per parent actually executes some other like sub functions. But this function is kind of like the final one in this stack. So there is no more functions coming after that. It doesn't call anything else. It just like calls some of the calculations, let's say, inside of it. So
I meant the one. Oh, I meant the one right after this one, like the whole black gap between Nokogiri and here.
So I don't really have like an answer for that. I kind of it's kind of a final function in some ways.
Okay.
So it's like,
Oh, is not referenced or something like that?
Maybe it's like a metaphor, like a paint job. We have multiple function called, and some of them has a long stack, some of them has a deeper stack, some of them have a bit shorter stack. So like 10 functions were executed, and some of them some of them have like 5 functions in it nested. Some of them have 3 functions nested. So, and exactly this one, maybe it's like executed and some nested functions, and then did some job on their own. And so that's why, yeah, it has maybe like this one. But it's also a guess, yeah, as Vasily mentioned, yeah, it's like a guess.
Yeah, but I think it's a right guess. I think because of the like functions have like different some functions, some of them have like zero-sum functions, and it's like a final one. It will just take less space on this like graph. Some of them that have like some more internal functions inside of the functions, they will be, yeah.
Okay, got it. Thanks.
Yes, Sean?
Yeah, I was actually wondering, where is this reading from? You know, we've got all this data, I guess, coming from all different places in pretty close to real time. So how does, do you understand what the architecture is in the background, or roughly?
I think we have some like measurements.
Would it be going into Prometheus or?
No, I think it's a part of our stack. It's like we just like measure lots of stuff, like I think maybe in our initializers.
Okay.
So yeah.
Right. Okay.
Yeah.
Jerry has a good. Sorry.
Yeah. Speaking of where it's coming from, I'm wondering if this is available somewhere that isn't live. So, like, say we wanted to look at flame graphs for a stack trace of something that happened like yesterday.
Isn't live. Can you clarify, please?
For example, if there's like, is there stack trace data somewhere that we can use to make a flame graph of a request that happened previously? Like if we're trying to examine performance from like yesterday, for example.
That's a good question. I don't think we store them, but I might be wrong. I think technically we can have like a possibility to store it, this information, because you can like, there is an option to export and import that. Maybe we can kind of somehow trigger this import, let's say, of these flame graphs for particular endpoint and have access to them. But I'm not aware about that. So it's something that I need to check.
Yeah, it's probably something that should be checked, because I think for Go services, we have like a Go profiler, but it's actually a feature of Google Cloud Platform, and it actually allows us to view their calls like this. Yeah, but for this particular graph, yeah, I think we like perform things in flight. If it's enabled, and then display it, because actually I've introduced one thing which is maybe not very useful, but it's on development environment only. If you are familiar with Bullet gem, which allows you to detect N+1s, in the development we actually also have a section which is called Bullet. And if we have N+1, we can click and it shows which records were inefficiently loaded. But this feature is only enabled on development because maybe it's too risky. Usually maintainers suggest enabling it only on development. That's why you have enabled it on production. So just to avoid some unexpected results. So this one is, yeah, only for development. Something like this.
And there's one more.
I noticed.
Yeah, there is one more
I
thing I
noticed
want to. Okay,
Yeah, sorry,
Okay.
I'm going to put my hand up now.
go for it. Yeah.
Oh, okay, sorry to interrupt.
Yeah.
I guess we have, if you go back to the original view, please, Vasily, before the
Original
flame
view.
graph, the performance bar. Yeah. So we have database. We have I guess Rails, right? Redis. We don't have Rails. So we have database, Gitly, and Redis. I said it's all our data stores. That's interesting because I was wondering, we don't have a representation of Shell or Workhorse, but a lot of traffic will go through those. Well, I guess Shell would be, I guess, probably not on this because we're not accessing it through the UI. But yeah, I guess Workhorse. Maybe we would look at adding Workhorse at some point.
Yeah, I don't think we have this integration for Workhorse.
Yeah.
Shell.
Yeah, I mean, Shell would make sense, I guess, because you're not accessing Shell when you're using the web page. But yeah, okay. Great.
There's one more thing I wanted to add before we wrap up. There is a plus sign, which is kind of useful because you can provide your request. For example, if you, we have this API request like that provides a list of projects to us, and we want to understand what's going on. We can copy this request. We can go to any page that has this performance bar. We can click plus sign, paste it, click enter, and then after some time we see this request. So for example, if you don't have the performance bar available for your API, then you can do it this way. So yes, and that can be also useful. Or for example, yeah, usually for that cases. Yeah. I think that's what I wanted to tell you about the performance bar. Find it as a pretty useful tool, and because we have many performance issues, you probably will use that for quite often. And knowing how it works, I think it will be useful for you as well. Oh yeah.
Yeah, that's great. Thank you very much. Yeah,
great. Thank you so much, Vasily. And it was a really great follow-up to the other tools that you showed us with Kibana. And that was really useful information because a lot of people don't know how to use some of these tools. That's really awesome. Thank you so much.
You're welcome. Thank you.
I'll stop the video.
Thank you.